Welcome back to 12 Days of Christmas Software Testing Strategy Style. And today we are talking about unit tests. That's the top of this filter here. And the way we've been thinking about it is that it's a bug filter. And each layer catches bugs on the way out so that only a tiny amount escape it all the way to production. So what are unit tests? Like, what are they? Modern unit tests, as we typically talk about them, were invented in 1995 by Kent Beck for the X-unit framework, or the J-unit framework, I think, was the first one. And they're all pretty much the same. You create an object that can live in isolation, and you have these generic that you're testing, and you have a class called that class underscore test, and that class has methods that have the word test in them, and you press a button and it uses reflection to look into it and say, call every method is called class, check all the asserts, get all the results back. If it's a green bar, if it's all good, make it a green bar. If it's all bad, make it a red bar. There's many, many different implementations of this, and you can do it in lots and lots of ways. This chapter is, in a lot of ways, it's the MAT style. So I find when I write unit tests, when I have to have a whole class named after it, I just can't have a bunch of tests. And then that class, I can't just have a bunch of T files where this class name underscore dot test. That class is actually real running Java code. And then every single assert I want to make that things are going right has to be a method. So one assert per method, which makes debugging easier. It's just an incredibly verbose, large amount of code. So you can buy a book on TDD. You can learn it from me. This book is in my style, so I have more than one assert per test. It's in the examples are in Ruby. A couple of interesting things that are in the chapter besides that. It's not all test-driven development. So we use Alistair Coburn's ports and adapters theory. So the external world are these different adapters, and we actually write code to hit them. So it's same thing here. It's a database, it's an API, something like that. So if that little thing that communicates with the outside world is a class that derives from some base class, we can create a different class that doesn't actually access it, that just stores what you passed in, and then our test interrogatory can say, hey, class, what did they call? What were the values that were used? This is very valuable if you're interacting with the database and you want to see what selects, what insert, what update statements are generated predictively. And it's not incredibly slow, which would be if we actually went out to a real database with production-like data. So what we're getting to is this book really, it's for people that are trying to work on the plane while they're trying to land the plane. We're doing software development in an existing system, and maybe it's old code, maybe it's bloated, maybe it's grown over time, maybe there aren't anything historical to not only are there no unit tests, but there's no little ways to drive the application from anything but the most public external way, and that is going to be slow and buggy and flaky, and there's a problem with that. So then what do? Well, we're trying to give some practical strategies, or at least a way of finding out what your strategy is through this book. So for unit tests, the thing I've had the most success with, you find this big, nasty, huge, terrible, untestable piece of goober that you can't pull it up. Because if you want to do these unit tests I'm talking about, you have to have one little tiny independent piece of code that can run it by itself. And you mock the whole world around it. So what we found in our consulting is that we'll go into organizations and they'll say, this is our unit test, singular. And there will be 200-300 lines of code to sort of fake the world out so we can finally do one assert. It's really simple, like we're gonna not use the user interface. We're gonna find a way to force a fake add to cart, which makes a bunch of assumptions about the world. Look, there's one thing in the cart when we're done that might or might not offer a lot of value. It might not, because those assumptions could be wrong. So there could be ways to add to cart that bypass all that, and then it turns out that your app has a bug that your tests didn't find. The chapter is also going to talk about mutation testing, and what do I mean by that? So we have all these unit tests that cover all this code. Theoretically, if I introduce a defect on purpose, if I change a for loop from 1 to n to 1 to 2 times n, or n divided by 2 or something, it should generate. If I mess up the code and I got a bunch of unit tests, it should file an error, right? It should throw a defect. So mutation is a technique, and there are tools and libraries and languages that do it for you, that change your code, run your tests, make sure there's a bug somewhere, and give you a report back. Hey, I made these changes, and it didn't notice. That seems kind of important. And that's mostly, now it does, I don't know how to get onto this. Maybe I could do a webinar, but it does actually build up in Ruby examples of real tests using a tool called, using a test library, and increasingly complex. And as you can see, I don't know if you can see, but I actually have more than one assert per line of code here, and I'm okay with that. This is more than one assert per test, and I'll show you how to do my style. And I will say that I'm more focused on, so a TDD developer practitioner will say, I'm focused on creating code that satisfies the requirements and get test suite as a side benefit. If you know me, I'm interested in generating an automated test suite and get a ton of cool developer benefits. Like, it forces me to build independent, isolated units. It forces me to have good design. It forces me to think about how my code will be used and design it so it's easy to use, because the first consumer of my code is myself as I try to call my own code. So those are the highlights from the developer. I just don't have time to get into the API stuff. There's a fair bit about API test strategy in here. Those are the highlights from the developer-facing, programmer-facing chapter. I think it'd be helpful to anyone, but if you write code in particular. And next we're going to dive into automating testing from a customer perspective. I hope to see you back tomorrow. Thanks a lot. Have a great day.